In this video, I'll go over how to do a couple of the problems in the motion graph's position versus time and velocity versus time assignment. The first question I'll go over is number 4. What is the maximum positive velocity? Hint, finding the slope of a line segment is how you determine the velocity. Each colored region of the graph indicates different periods of motion in which the object is going at constant velocity. So to find the velocity, we just need to find the slope of each segment. For the first segment, we rise 3, and our units, since our y-axis is position, would be meters, and our run 1, 2, 3 seconds, and that would reduce to 1 meter per second. Our next segment would be the purple line, and we rise in the negative direction 1, 2, negative 2, and we run 1, 2 in the positive direction over 2 seconds, and that would reduce to negative 1 meter per second. The next segment, we do the same thing, but it might seem a little odd because when we try to run, it's like, well, it doesn't go up or down. And so when we try to rise, and so our rise is going to be 0 meters, and our run is 2 seconds, but that reduces to 0 meters per second. And so you would do the same thing for the rest of your graph and determine what the overall greatest positive velocity would be. I can see right now that our next two slopes, the yellow one is negative, and then the green one is going to be another 0. And so our greatest positive velocity is 1 meter per second. The next question I wanted to talk about was number 9. Calculate the velocity for each motion segment and draw it on the graph below with the velocity on the y-axis and time on the x-axis. Hint, each segment will be represented by a horizontal line indicating constant velocity for that specific time segment. The first one has been done for you as an example. All right, so what this graph says is the velocity is a constant 1 meter per second for the first 3 seconds of time. And let's look back up here. We can see, well, yeah, our velocity was a constant 1 meter per second for the first 3 seconds. And so our next region would be here, and we know that the velocity was negative 1 meter per second, and it went that velocity for a total of 2 seconds. And so our next line would be, and let me keep the color consistent. So negative 1, for 2 seconds. And you would continue on for the rest of the different segments and complete this graph. The next question I'll explain is number 13. What does it mean when the slope is flat on a position versus time graph? All right, so I wanted to point out that we have this question. We're asking about a flat slope on a position versus time graph, but number 14 is going to ask the same question except on a velocity versus time graph. So they're going to mean two different things. So on this graph, position versus time, we already talked about it. If the slope is 0, or if the graph looks flat like it does here, then we know that the object has a velocity of 0 meters per second. So in other words, the object is not moving. So see if you can figure out how that same question, but for velocity versus time graph, differs. Good luck, and let me know if you have further questions.